Welcome to the Digital Analytics Power Hour. Tim, Michael, Mo, and the occasional guest discussing digital analytics issues of the day. Find them on Facebook at facebook.com/analytics hour and their website analyticshour.io. And now, the Digital Analytics Power Hour.
Hi everyone, welcome to the Digital Analytics Power Hour. This is episode 71. Can you calculate the exact time and date an anonymous visitor becomes good at the game Super Mario Bros.? Well, we've been looking into it. And apparently there is this thing called reinforcement learning and artificial intelligence that has all the answers. Our problem was we were struggling to come up with the questions, 42 and all that. So to be clear, this episode may or may not be about how computers dream of electric sheep. We have TensorFlow simulating the podcast in real time, so just bear with us. It will get better over time. I want to introduce some of our standard co-host variables in the form of Tim Wilson.
Philip K. Dick reference. Good in the opening. Heidi ho.
And Mo Kiss.
Hi guys, how you going?
Going great.
Oh God, every time. Every time.
What? No, I was ready. I said going great. Is that okay? Is that
That's a great response.
Adapt and learn. And I am Michael Helbling. All right. Our guest variable is fulfilled by none other than Matt Gershoff. He's the CEO of Conductrix. He is a second-time guest on the podcast and a frequent mentionee on the show. Welcome back, Matt.
Thanks for having me.
Awesome. Well, Matt, we're excited that you can help us reinforce what we've learned about reinforcement learning, because that's sort of where we're headed tonight. So you did.
Oh, no.
You see what I did there?
Yeah.
No, so we're to kind of kick things off. I think this goes all the way back to February at Super Week and the talk you gave there, and maybe as a starting point, sort of define those relationships between machine learning, AI, and reinforcement learning to kind of create a base level for our listeners.
So the one way to think about machine learning, which is basically, I think, an easier way to think about it without getting hung up on is this particular method part of machine learning or some other method actually machine learning, is really just to think about machine learning as the intersection between statistics and computer science. And so with computer science, it's really the study of programs, right? And it's usually programs that human beings write the programs so that they're executed on a computer. Machine learning is where we're going to use ideas from statistics, and we're basically going to learn programs such that they execute for some sort of particular task. So you normally write a program, it's in order to do something. And the idea here is that rather than having a human being write the program, we're going to have a procedure, almost like a factory program, a machine learning process, which is going to generate its outcome are going to be programs. And the programs can be of various complexities. But the main idea is that we're going to have, rather than having to write the thing, we're going to be able to learn the program.
So stepping back a little bit, what is the application of machine learning? Like when we say the intersection of computer science and statistics, the applications of it, I guess from a digital analyst perspective, and I think I've sort of struggled with this, and I have momentary glimpses where it makes sense and then it goes away. But in the context of digital analytics or digital marketing or optimization or making the site work better with data as an input, with machine learning, is there inherently need to be a feedback loop that you're trying to control things in addition to? Is it measure and control? Is that machine learning, or is reinforcement learning where you have to be in measure and control?
Yeah, I think let's not confuse. Let's just start simply, and it's just basically you have a task, right? We have some sort of task, and so what are some of the tasks that a digital marketer has? Well, maybe the task is to send out a particular email such that you get people to sign up, right? Or maybe it is you have a website and you want to have it present a particular product or offer that's compelling to the particular user, right? So you have some sort of decision, you have some sort of task that you need to take. And so the idea behind machine learning is rather than have us write the rule, as you might currently I've done with a business rule where I'm going to map some scenario to a particular action. So if I see a particular type of user, say a new user, we should offer them this product. If we see a repeat user, we should offer them some other product. Instead of having the person write that or the marketer write that, instead we're going to learn what those rules should be, what the mapping should be. If you really think about it, just a set of rules really is like a program. It's like sort of a simple program. And so that's really all you really should think about is you have a task, and how do we go about learning a procedure for executing on that task in a way that is, has high efficacy, does really well on whatever our performance metric is. And so that's really what we're trying to do.
And just bringing it back, so before we kicked off the show, we obviously were going back talking about this topic a little bit. And one of the points you mentioned that I found really interesting was that often the role of an analyst, and when we're trying to understand, say, for example, email sends, we're looking at historical data, we're looking at the past, and then trying to use that data to inform our decisions going forward. And it sounds like one of the real benefits here is that because you've got this program that's learning, it's actually based on current and future behavior. Is that accurate?
Well, it could be. It depends upon the data that you have. But if we're just talking about it as a general approach, its goodness, its efficacy or its quality is going to be, a function of what you put into it and your skills or your analyst skills or whomever is building the programming or doing the machine learning. So it's sort of like art, right? And it's okay if something is crappy, it still can be art. Right. So there's a difference between art and good art. And so there isn't necessarily some sort of bundling between goodness and machine learning. And just machine learning is really sort of the process of generating programs, right, through either the interaction with the environment or through data. Then we can decide or assess how good it is and whether it's been worthwhile, right? Because there's a cost and we're adding complexity and we have to build these things and we have to maintain the data and we have to ensure it's consistent with the experiences. And if we're trying to automate with it, and there's a lot of complexity that we have to factor in to whether or not in aggregate it's been worthwhile to go down this route.
So, and maybe taking one more run at this, because I do feel like there's a group of people who are operating on an understanding of what it is we're talking about. And then there's a group of us who maybe are still struggling. One of the things that I've now pointed people to and gone back and watched multiple times was from your Super Week presentation. And I think a lot of people have seen it, is the Atari breakout scenario that was using Google DeepMind. So putting aside that it's DeepMind and all that sorts of fancy stuff, but conceptually it made a lot of sense to me, because it was, you have very limited levers you can pull, which if I equate that to a website or something I'm doing, let's say all I can control is the copy in this box, or all I can control is one of these 4 offers. And then I've got a defined outcome with Atari Breakout, which is I want to maximize my score. And then with what was a simple, and you kind of alluded to it or you stated it earlier, you have a clearly defined performance metric and you have clearly defined kind of what can be varied. It is a trial and error that is smart enough to start figuring out what works and what doesn't. Is that a fair description of the breakout example? And then I want to try to kind of equate that to a website. Yeah,
yeah. So I just want to get back to Mo's original question. So I just want to make sure I'm clear about that. At like a higher level, you can think about machine learning. And then underneath machine learning, there are different sub-problems of machine learning. One of the sub-problems is normally known as unsupervised learning, right? And that's like, when you guys sometimes are talking about cluster analysis or segmentation, it's really about grouping things together, right? Or maybe you have a lot of documents and you're trying to figure out what the topics are for the documents. And we're trying to group like things, right? And we're trying to separate unlike things. And then there's also something called supervised learning, where we already have the data. And that's something like, let's say you wanted to do image classification, right? So you have a set of images and you're trying to find out whether or not there's a dog in the image or there's a person in the image or a cup of milk in the image, whatever it happens to be. And so maybe we already have images that have labels assigned to it, right? And so there really isn't any interaction that needs to take place in the environment. We have the data, and then we're going to learn a model. We're going to learn a map between the pixels in the images and the labels. And that's also supervised learning, but that's machine learning. Now, there is no trial and error there. There is no learning from the environment. There's just a set of data that we have. And so we know whether we got it right or wrong because we have the truth, right? We already have like the data set which says what the right answer is. And then there's this third thing, which is what you were alluding to with what Google DeepMind is doing. And that's maybe a little bit what we'll talk about with reinforcement learning, which is where we don't have the data. And so we actually have to go out and interact in the world. And we don't actually ever get the right answer. And it's just like, when you're in a new town and you move to a new town and you're trying to find out what restaurants you like. When you go to a restaurant, after you eat there, you don't get a message coming back. You say, you just ate at the best restaurant or you just ate at the worst restaurant for you. You just get a utility like, wow, I really like that restaurant or I really hated that restaurant or somewhere in between. And so you just get a reward metric. And so it's just like reinforcement learning originally comes, I believe, from psychology with just reinforcement learning with like a dog and operant and classical conditioning, and you give a reward for good behavior and you withhold the reward for bad behavior. And so in that case with Breakout, that was a case of where Google DeepMind was using reinforcement learning to learn how to play Atari 2600, for those who remember from back in the, I guess, early 80s, late 70s, I don't know. But the thing is that Google DeepMind learned. They did a lot of work with deep learning and reinforcement learning, kind of blending the two together. So I kind of learned like how to play these video games, and which all that really is it's a map between the pixels in the screen and whether to move the joystick up, down, left, right, or to fire the button, right? And so, but the only way they could do that, they didn't have data on all the moves. They actually had to like play the game. And so that's the distinction, is where either you have the data and you have the labels or the right answer for each classification or each regression problem, or you don't, and you have to use this trial and error learning. And that trial and error is much more like how us humans or animals behave in the world. Is like we act in the world, we do something in the world, we see how the world responds to us. So we either like how where we are in the world, or we don't like where we are in the world. So maybe you put your hand over the flame when you're younger and you don't like that, or you eat some ice cream and you do like that. And so you get positive, negative rewards, and over time you start to learn what actions to take in different scenarios based upon the reward. And so it requires this kind of extra resources to actually play out different experiences or try out different actions in the world to see how well it works.
And is there a piece of it that also the world is changing, so that even in the case of something like Breakout, you would expect the computer to just get better and better and better and better until it reached some logical max, whereas in the world that we're in, where the seasons change, the products change, the consumer changes, all of that is changing, that if you're doing, and maybe continuous optimization is the wrong way to say it, but we talk about kind of classic A/B tests, that you run an A/B test, you get the answer, and we probably treat that, I know we treat that as way too definitively, that this is a 13% better than this other, and we want to treat it in that kind of black and white way, and then we move on, and we feel kind of set it and say we fixed that. We came up with a better solution and went with it. And there's I think a ton of problems with that mindset, but if the machine is running and the machine is continuously learning, it can find out if the flame is hot and it burned me now, but maybe a week from now it's not going to burn me because I'm going to keep learning and keep feeding information back. Is that a fair statement?
Yeah, Tim. So I think you bring up a good point. And what you're talking about here, I believe, is the idea that the world might be non-stationary, right? And so things can kind of change over time. But that isn't particular actually to the reinforcement learning problem or the learning from trial and error. That's actually true of our classification problem, right? It could be also true of that, and it can also be true of our clustering or segmentation problem. So I don't want you to think, or I don't want your listeners to think that actually the idea of the fact that things can change over time, or if we're only looking at something in a particular season or a particular day of the week, that's an issue that's only something that they're going to have to deal with in this trial and error learning idea with reinforcement learning. That's actually true with the classification. There could be something with images where labels sort of change over time, or the distribution of the images that you get changes, and so you actually have to keep learning that as well. So that's an important point, but it's not something that is is unique. It's not an issue that's unique to reinforcement learning. But it is true that if you're doing something online where it's adaptive, where rather than, there's kind of two ways to do machine learning. That's not exactly true, but there's one way to look at it is that you can either do it in a batch. So you collect the data, right? And then you build a model off of that batch. And so you have your learning from that big bundle of data that you have. Another way to do it is what's known as online learning. And you can do online learning for unsupervised problems, for supervised problems, as well as for reinforcement learning. So it's not unique just to one of those types of machine learning. And online, it's basically the data comes, you treat the data as events or as sort of a stream, and you kind of keep updating your model as the data comes in, and you take advantage of the data as it comes in. And what that lets you do is it sort of lets you forget older data or older history and put more weight on newer data. So there's this idea that part of machine learning or part of AI or part of learning in general is forgetting. Like in a way, in order to learn, as things change through time, you have to be able to forget. And you can model that, or you can embed that in your machine learning algorithms. And so that would be an approach, that would be something you would want to do if you had a problem where you did have some sort of belief that you thought that the world is kind of changing over time, or your models or your belief about the world is perishable. It's like, how long is this really going to be useful for? And there's some knowledge that we have that, is 100 years old, right, and still true today, or still is useful today. And there's other things that as the world changes, like, knowing how to, use a fax machine or whatever is really not that useful anymore.
Okay, so how much data do I need to be able to do this?
Well, it really depends upon the problem. I would think, in general, you probably want to be, honestly, you probably want to be in a fairly data-rich environment. But why do you want it?
So data-rich environment means like terabytes of data?
No.
Oh,
no,
okay.
I don't think so. In fact, if you're doing any of this reinforcement learning stuff, or you're doing, think about it this way. When you're running an A/B test, you're really trying to learn what action to take, right? Well,
right.
Oftentimes, there's two kind of forks to why you might be doing an A/B test or an experiment. If you're a scientist or you're doing some sort of research, you're trying to learn some general statement about the world. You're trying to learn some generalizable inference about how the world works. And you might actually be doing that as a marketer, right? You might want to understand some generalized behavior about how customers behave in certain circumstances that you could apply kind of across the board, right? And that's a case where you want to be fairly sort of rigorous in your experimentation. But then there's other types of problems, which is where I think most companies are probably using A/B testing, which is really they're trying to optimize a process, right? And so in that type of problem, it's really about, a lot of times you have people running tests and they don't have terabytes worth of data, right? They have, tens of thousands of observations or hundreds of thousands, but certainly not terabytes. There's no need for that.
Is it a sort of a faulty to look at it as the size of the data set? I could do one email blast to 1 million people and I could wind up with a lot of data, but that hasn't been any data that I've been able to, I guess if I very, very
observe longitudinally.
Or if I've even very carefully designed it, sure, if I sent, 10 variations and, mixed it all up, maybe that would work. And I guess I'm back to, it feels like it's easier to understand, and maybe this is because, Matt, I've seen enough of the Conductrix stuff and how it works, and it makes total sense when you've said, I have 3 options I can control here, 3 things I can change here, 3 things I can change here, and I know X, Y, and Z about, every visit that's coming in, and I have a steady inflow of visits, and in that sense, sort of, and you and I a couple of weeks ago had a little bit of an exchange. Like I look at when Adobe went from Adobe Test and Target, and everybody thought of them as a testing platform, to Adobe Target, that part of that's what they've been, even Adobe, and I guess Google probably as well. I don't want to go down the vendor path, but this idea that a bunch of things about your visitors, and some of the stuff matters and some of it doesn't. And there's a limited number of things you can control, either because you haven't created content to provide various options, or it's just not something that makes any sense to be changed, or the infrastructure doesn't support it. And don't you have to sort of start by defining that universe of saying this is, and I kind of want to have a steady stream coming in so that I can change things. No? You've got the look of, what the hell did you just say? Oh my God, Tim, you were so wrong. I mean, I'm trying to figure out how to get this out of like a very narrow, I can define areas where I say this totally makes sense. And then I look at the other, I feel like 97% of questions that analysts are asked or are trying to answer. And I can't bridge that gap.
Yeah. So first of all, it's like there isn't going to be like one way to do something. And so an analyst or anyone working in this space, they have sort of a broad set of tasks that they need to perform. Now, if one of the tasks is to try to figure out how to map experiences to customers, I think that's what we're kind of talking about. And that's what that's what Conductrix lets you do. That's, I assume, what Adobe Target does. And there's others out there. And if that's the task, then there's really, 2 to 3 types of sub-problems there. So one, let's say we're trying out new experiences. So let's use what's a case. So it's like maybe there's it's a travel site and they're trying to sell vacation bundles. And there's like maybe the family vacation, there's the single vacation, and then there's the adventure vacation. Let's say, right? So maybe there's three possible product offerings that they want to present to different users, and they're not sure what one has the best efficacy and for whom. So number one, these are new bundles, and so they have to first do some trial and error learning, right? And one way you might do it is you might use A/B testing. And I think that's the general mental framework or the general approach that is, usually discussed or promoted in the industry, right? But really, it's not necessarily about A/B testing. It's really about this trial and error learning because you don't have data about these 3 different offers. So the only way to learn about them is to actually try them out. So it's starting to fall under our reinforcement learning framework because you have trial and error learning, and that's one of the components. We actually have to see how well each one does, so we have to sample. And then 2, we're going to need to do some predictive targeting, right? We're going to have to learn some sort of mapping between different types of users and the value of each one of these, right? The conversion rate of each one of these vacations. So we're going to want to look at, as we offer up each vacation package, we're going to also want to look at, attributes of the user. Right, and so in the standard web setting, it might be where they're coming from, or it might be the type of browser, but it could very well be that there's additional data that the client actually has, and it could be their tenure, it could be an RFM model, it could be a lifetime value calculation, it could be anything that is an input to this, and so that's where this part is kind of similar to the supervised learning problem or a regression problem or a classification problem where we're trying to learn a map between attributes of the user and then what vacation to offer them, like what the conversion rate is for each one of those. So what we need to do is we need to learn that relationship between the user and what offer is best. But the only way to collect the data is to actually go out there and interact with the world, right? And that's basically the reinforcement learning problem, or that's basically what was known as a multi-arm bandit problem, a contextual bandit problem.
Can I just clarify? I just want to make sure I'm following this because, to be perfectly frank, this is something that I'm just starting to get my head around. So let's take your email example, right? So we've sent out our 3 emails to our 3 groups. If you were using reinforcement learning in this context, would it be that, so the emails go out, person A converts on the family email, and then part of that feedback loop is that it says, yes, you did good. This is the treat reward side coming in. So we learn that this is the behavior that we want versus person B that didn't convert. So that's the behavior that we don't want. Is that kind of breaking down what the learning's actually doing?
Yeah, it's as simple as that. So let's just use a website so it's a little bit more continuous as opposed to adding a little extra complexity from the email idea, which is going to be a little bit more discrete. So a user comes in and you take a look at their attributes, like just data about them, if you have it, right? So let's say we do have some data. So let's just say it's, the day of the week, day part and the geo, whether coming from Sydney or Melbourne or Brisbane or whatever, and the browser. Okay, that's not great data, but for this, it doesn't really matter just to think about it. So we take a look and we see what those features are, and then we kind of randomly sample and we select one of the vacation packages for that user, and then we wait, and then we see, well, what do they do? Well, in this case, do they convert or do they not convert? Or if they do convert, like what's the value of the package, right? The vacation. And then we get that information back, and then what we do is we kind of apportion a value of that conversion event, that reward event, right? That good thing that's happened in the world, back to each one of those features that was active at the time. So if they were coming in on Chrome and they're coming in from Sydney at night, then each one of those features would get a little share of the conversion event. So their weights, their input in predicting the value of that particular vacation, let's say it was a family vacation, goes up a little bit, right? And then let's say another user comes in and we offer up the signal package and they don't convert, right? And so we had predicted for them, we looked at the weights for each one of those features and we come up with a little score. And now we're overshooting it because the person didn't convert. So we're actually going to decrease the value for each one of those features that was active at the time, right? And this is just basically simple online regression. This is going to be a little complicated to talk about over a podcast, but that's basically how it works. Like in an online approach, you take an action, you see what the reward is, and then you go back and assign. You either push up the value for each one of those features if you had a good thing happen, or you bring down the value of each one of those features. And over time, it starts to converge, and you can start saying, well, if the user is coming at night on Chrome from Sydney, the best predicted option is the family vacation option. And if they have other sets of features, maybe they're coming in on Facebook during the day and coming from Brisbane, maybe it's the signal vacation that has the best conversion prediction. And then you play that.
So let me try, I'd say, flipping it around to kind of what I think is sort of the traditional way that testing and optimization teams will approach. They may start with their first test and say, we have these 3 vacation options and we're going to run a test, even split across these. We're going to run it and see which one performed best. And maybe nothing comes out as being best, but then we always say, but don't stop there. Even if there's not a clear winner, then go and do your segmentation after the fact, because that's where you're going to uncover the gold. And then potentially you say, well, it seems like what I discovered was that, people coming from Sydney prefer this option. Now let's do maybe another test where we actually do some targeting, and it's kind of a human, slow and very discrete steps of run it for the entire population, then take that batch of data and start trying to find ways that you can sort of tease it out. And then either decide you're just going to do targeting on that or do further testing. Is that whereas what we're talking about here is a little bit of turning that.
It's automating it
upside down.
Well, it's automating it, really, right? It's kind of automating that process, right? And so that's going to be a trade-off. And automation in of itself isn't necessarily going to be, always the best approach. I mean, it really just depends upon the scale of the problem and whether your organization has the existing infrastructure and sort of sophistication to manage that. But there's nothing wrong with what you first suggested. I mean, it isn't necessarily wrong, especially if you're going to rerun a test after you think you've found some potential areas of opportunity. As long as you rerun those tests and just to see if there's some sort of return, there's nothing wrong with that. But what we're really trying to talk about here, if you're talking about machine learning and you want to apply it, you really want to ask yourself, well, beforehand, really just think through, like, what types of returns do we think we're going to get by doing this? And the whole idea of it is to help kind of augment and automate parts of the procedure so that you can do this faster and at scale and at a complexity that may not be so easy to do with having an analyst involved. I mean, the idea is at this micro level. And so the idea is to sort of, push down some of these low level, high transaction, low risk decisions into the application layer itself and, free up the analyst to be doing more important stuff or just to be maintaining this and managing it and like help guide it, because it's not like something that's going to be done, in a vacuum. I mean, it's still a hard problem. Just saying the word automation doesn't mean it's necessarily going to do particularly well, and it certainly needs to have.
But I think if in a static world where you're trying to decide between 3 vacation types, where that's fairly static, you could say, well, the cost to do automation may not be worth me just kind of doing it as a smart, experienced analyst. But if I know that I'm going to be rolling out new offers and I know seasons are going to be changing, like there's this sort of image in my brain of it's running and it maybe starts off static. I've got these 3 vacation packages to deliver and it's kind of figuring it out and it's kind of cranking along. But now I can come up with a different vacation package and I should be able to, I think, just kind of throw that into the machine and say, that's all I had to do was come up with another idea. Maybe look at what seemed to be working and didn't work to kind of inform that offer. But now I don't have to go through all of the steps of setting up planning, figuring my start date, figuring my stop date, figuring my new analysis. If I've automated that piece, like it seems like, and I may be oversimplifying it, if I know that I've got certain areas where I'm making offers on the site, I know I'm going to have new offers coming out driven by all sorts of external factors. What I'd like to know is that I'm going to be able to add that offer into the mix and then let the whole thing kind of reach a new equilibrium, figuring out that, oh, well, now instead of being, new visitors from Melbourne, it's now new visitors from Sydney actually fit better here and returning visitors from, Melbourne or something like that. Look at us like pretending that I'm going to drop in Brisbane and Perth and then I'm done.
I'm loving all the Australian references.
Yeah. How you going, Tim?
I'm going great.
You could definitely do that, and that's like in the literature that's known as, I think it's the restless bandit, and it's basically you kind of have arms that are degrading and you're pushing in new arms, and we definitely let you do that like in our software, but that's like it's still hard, and you still need an analyst to be thinking exactly what the problem is. So yeah, in that type of use case. And you really just care about optimizing the process. So you're getting different types of information out from, when you're doing something like RL or, and a bandit is just a subset of sort of a reinforcement learning problem where you're sort of adaptively making these selections over time. It's really about trying to find the best arm. And we're really trading off trying to find the best arm quicker with uncertainty about the conversion rate or the value of the suboptimal arms. So we're kind of like reallocating resources. That's really all an adaptive procedure is doing. So when you're running a regular test, normally it's like each option A, B, and C, or each of the vacations gets the same amount of data, and so there's roughly the same amount of uncertainty in the estimated value of each of the vacations, each of your A, B, and Cs, right? Roughly, because there's the same amount of resources, the same amount of samples have gone into each one. When you're doing something adaptive, like a bandit, even if it's doing something, some of the simpler procedures, we don't really have to talk about each of the procedures, different approaches, unless you guys want to. But regardless, it's really about over time sort of reallocating resources from what we think are sort of the lower performing arms or options to the higher performing ones. It's almost kind of like you've got your soccer team or your football team, and so you have all these players at first, and they all get time on the pitch, right? But over time, as you start getting closer to the season or you get closer to the championship, you start benching a lot of the players, and only the ones that seem to have been performing very well are the ones who wind up playing the game on the pitch. And it's kind of like that, right? So it's like you kind of like at first everyone gets a chance, and then you get less and less playing time if you're not performing. And that's really the same type of thing. That
analogy actually really helps things click in. But I'm just wondering, I'm thinking back to that.
And we're out of time.
Oh my gosh.
No, don't listen to me.
Okay, go ahead.
So I'm thinking back to that Atari example, which I watched and found very entertaining. So I feel like coming client side and that bringing that analyst point of view, people have kind of just gotten used to, or they're used to A/B testing. They pretty much understand what it's doing. People are comfortable. So as an analyst, if I'm like, actually, here's another thing I want to try out, one of the I can already see it. One of the big hurdles to get over is that people will want to look at the Atari game in that very early stages where it hasn't learned yet how to do things well and it's not performing really well. How do you manage that until it gets to a stage where the reinforcement learning is performing well and really giving you those results? How do you manage that in a business context of getting people on board, getting them used to trying something different when, early on, it might not be great?
Well, it's even worse than that. So if you, you're talking to the wrong person. Like, I'm a bad sales guy, because I'll tell you it's hard. Like, everyone else always says how easy all this stuff is and how their software is going to be. But it's an inherently hard problem, and it's harder than that because your assumption is actually one that I don't want the listeners to think is actually true. It's not true, actually, that it doesn't look like it's performing good at first, and then suddenly it will perform well. You have no idea if it's going to perform well because, remember, it turns out that the marketing problem, and this is why the analyst and the marketer is so valuable, actually. They actually want this stuff to be hard because if it wasn't hard, they wouldn't be valuable. And it turns out that they are very valuable because these are very hard problems, and they're harder than, in a certain respect, they're much harder than the Atari problem. Because the Atari problem, if you think about it, while it's a very complex representation that the algorithm needs to map the pixels into in order to learn how to play the game well, we know that you can play the game. You already know that there's a solution. Because you played the game, you can look at it, and we know going into it that the images on the screen, the pixels of the screen, we can look at that and we can play in a way that performs well. We know there's structure there. But let's think about the marketing world. That's not the case at all. How many times have you or your listeners run A/B tests and it's been inconclusive? In fact, Tim's first analogy there, discussion was, it usually doesn't work at first for the whole population. Well, think about it. That means that actually there is no structure. There is nothing to be learned. It's A, B, and C are equally poor or equally good. And so that's actually the hardest problem. And that's something that actually at Conductrix we spent a lot of time working on, is that the problems that the marketer is the agent or the intelligence is going to find itself in are often going to be these very noisy problems, right? And so that's why it's really hard. And so really what it is it may never find anything because there may be no map. And so what you want the system to do is you don't want it to present the machine, because remember, the output of this is a little program. And by program, I just mean, if the user has these attributes, then do this. We represent it as a decision tree, but it could be represented as a bunch of numbers. There's lots of ways to represent this program, but it's really just a way of putting an input about the user and getting an output of what action you should take. And the thing is, what we don't want is for that program to be very long if there is no structure, right? Because how complex that program is really saying how much structure there is in the problem. And what I mean by structure, it's if a user is coming in from Melbourne and they're coming in at night, then they have to get this vacation. But if they're coming in from Melbourne, but it's during the day, but they're actually on Chrome, then they should get this other vacation, right? And you have a whole list of rules. The more rules you have that actually make a difference, that implicitly, it's kind of like the flip side of how much structure there is in the problem. And so if you think about it at the edge case, if there's no structure, you don't need any rules. It's just pick randomly. Pick A, B, or C, it doesn't matter. And so you have a really short program. It doesn't, you can do anything you want and it won't matter. And that actually often is a lot of the scenarios. And it's important for people to realize that you don't want to sell them. What's important, I think, if you want to manage expectations, is even if you could sell it, if you were to make it seem like it's magic, long term that's detrimental, and you don't want to sell people a bill of goods, and you want to be honest with them. And it's these are hard problems. Now the question is if you do think that your marketers are coming up with different experiences that do differentiate your users, then this is the type of thing you want to do because you can do it at scale. Now what we do is that we have a meta A/B test, right? You don't have to do this, but this is how we think this is best practice. And so we have our machine learning, our RL program, which is trying to learn this assignment between users and experiences, and it's doing all this adaptive stuff. And so what we do is we sort of always have some subset of the users that are just getting randomly assigned, just like you would in a regular A/B test. And so the adaptive, the machine learning is just another arm or is just another experience in this larger A/B test, this sort of meta A/B test. And so we look at like the vacation, the 3 different vacations. Some users get randomly assigned to each one of those. And then we keep an account of when users were assigned by our little machine learning, our little RL algorithm. And then we can see, well, how much difference is there actually when people are going through the machine learning versus if we were just to like randomly select over these 3, or we just picked A, B, or C. And then you can see what the marginal lift is. What's the incremental return to targeting, which is really what you want. And then a lot of times there might not be. I mean, if you think about it, like let's say you had some sort of problem where, I know vacation is like a really lame, I wish I thought of like some better example, but like it's like some vacation that everyone wants, right? It's to Tahiti, right? And so it doesn't matter. You don't have to target on that. Like maybe everyone wants to go to this free vacation to Tahiti. And so targeting is going to have no value because no matter what, the answer is always Tahiti. And so if the answer always comes back to Tahiti, then it's like you get no return from doing any targeting, right? You're just going to pick Tahiti. And so it's that type of thing, which is what the analyst needs to be thinking about, and how to approach it, and how to ask, well, what types of returns do we need to get on average for this type of approach to be useful? And then I would just position it as an experiment. Look, I mean, if you're in an organization that actually understands the value of experimentation, not the ritual of doing experimentation, but you're incurring some sort of risk, some sort of cost to collect information so that you can maybe use it in the future, has some sort of future value, right? Perhaps. Yeah. Then that's how you position it. Like, let's do this as an experiment and see how this works, right? Not like you can't guarantee anything. And I know that's unsatisfactory, but the reality is that if you're in the world of statistics and we're in this sort of inductive learning, we're using experience to make statements about the world to learn. Our knowledge is coming from experience. There's always uncertainty. And anyone who's like trying to like convince you that they can give you this, the answer is A or the answer is B, is either ignorant or is disingenuous. Because you can only say what the answer is on average, and you can only say, you have to assign some sort of certainty. Like we're some sort of, you're making decision under uncertainty. And so the question is like, we could do this extra, we could collect more information that would reduce our uncertainty, and then you can estimate the value of reducing uncertainty in your problem. So, I mean, I know that sounded a little bit harsh, but I do think it's important that this can't be magic. We're supposed to be, this is like scientific marketing, right? It's the science of it. And so we need to be very honest with our stakeholders.
So what I think I just learned there is that we should always have an AI running in the background that does nothing.
That is absolutely not correct.
Oh. So close. No, I had this.
He's just saying that because really he's thinking is like that's a great idea for a product.
Who can tell me? Who can tell me I'm? Well, he said disingenuous or ignorant, and I was like, why not and ignorant? So no. So, but that's the other thing is going back to that issue that you just discussed. There's also the prediction of external factors that an AI is not going to be ready for, right? And how good at adapting should we expect a reinforcement learning system to be? If I know Lord is from New Zealand, but if she finishes a concert and then she yells out to everybody, I buy all my clothes from the Iconic, and then all of a sudden the website's flooded with new customers, the reinforcement learning, I don't know if Lord is big in Australia. Maybe there's not a thing. She's big in the U.S.
She is. It's all good.
I could go Kylie Minogue, but that would date me.
Lord is a musician. Okay.
Yep, got it.
Yeah, Tim, okay. You would actually like some of her stuff if you would out of your folk prison.
Oh,
my Americana world.
Yeah. So no, but does that make sense? That's a long way to ask a question, but that's sort of Tim's thing. So I'm trying to steal it. And no, I'm just sorry. Hey,
fuck you.
That's always true. So that's not anything that's like an additional constraint on like an automated approach. That would be true if
it would be true if it was humans running it too.
Yes. Yeah. So of course.
So it'd
yes,
still
the
be a
answer is
challenge
yes.
for any system,
Yes. That's
human
why you
run or
need-
machine learning, procedurally generated.
Yeah, if it does not have, like you have these one-off events that are these random stochastic events, then yes. But now, as an analyst, you might say, oh, actually, what we need to do is like model whenever these concerts are happening, and then and actually model day from one of these concerts, right? If she's always up there talking about the iconic and how awesome the clothes are, then you might want to include that in the model and include that in the bit of data about the world that you want to be paying attention to. And if it's a one-off, then we get back to the point about forgetting and so what? And so you're off by that one day, and there's like some effect to maybe the model, but if you're doing something online or you rerun the models or whatever, you can kind of refresh the thing. But yeah, if you're always having random events, if there's no real structure and it's just like this chaotic world you're in, then you couldn't learn. The world has to be amenable to learning, right?
Well, or those random events repeat themselves. So, like, what if annually this event was random, but it kept happening? Then it would learn.
Matt, can I just ask a quick
Yes,
question?
I know that means it wouldn't be random anymore, just for the record.
Can I just ask a quick question? If our listener is an analyst out there and they want to start learning a little bit about this and I guess dipping their toe in, have you got any suggestions of, I don't know, where to start or a problem that might be a little less complex that they could kick things off with? Like, have you got any pointers?
Oh, you mean other than looking at conductrix.com? Then
other than that.
Yeah.
I mean, there are a lot of great blog posts on conductor. I will say that for Matt has done a yeoman's task of trying to explain some of these concepts on the Conductrix blog.
Yeah, and they're very non-producty too. So like, there actually is real content on there, and it's not. There is no real sales component there. That was actually going to be one of my last calls, but yeah, you know what? We'll put up a set of resources for the listeners, and you guys, if you are so inclined, you can put that on the on the podcast homepage, and there'll be a set of lists.
Awesome.
That'd be great.
Speaking of last calls, unfortunately, yeah, we've got to start towards our wrap up. Heady stuff, but I think I learned about 3 or 4 new things. I'm excited to kind of bring back to the team that actually does this kind of work that I can talk to, because this is not in my field, but I talk to people who do some of this stuff. But
you're going to open with the scheduled annual random event.
That's right. And now all rise for our random event. Is it a sale? You'll never know. Okay. So one of the things we like to do on the show is like to go around and do a last call. Something that's going on that we think is interesting, maybe be of interest to our listeners. So Matt, you're our guest. Do you have a last call?
Yes. So
besides the one you just did?
Yeah.
For everyone
out there, that's actually the first call. That's first call.
That was first call. There you go.
No, actually, since we were talking about, I know there's a lot of folks out there who are interested in learning more about machine learning and deep learning, and so I highly recommend. There's this really great guy. He's over at Google DeepMind now, but he used to be at Oxford, and before that at one of the Canadian universities, which, by the way, that's really where a great deal of the world-class research is coming out of Canada at the moment. But this guy, Nando De Freitas, and he has a deep learning set of lectures that he gave at Oxford. And I know that it sounds kind of like super intimidating, but if you have some basic capacity in analytics, I highly recommend going to his YouTube channel. And there's about 17 lectures. And even though it's called Deep Learning, is like the title of the class, the first 10 lectures really actually just start from the very beginning, talk about basic linear regression, talk about logistic regression. And so it's actually a really amazing arc of starting from the very basics of machine learning and going and building in a very modular way, which actually is what deep nets do. They're modular, in learning, from the very beginning to the some of the more advanced stuff like the convolutional nets, which is what most of the image recognition software is around. So if you actually want to know the mechanics about it, great resource.
Nice.
Michael, you want to go second?
I would love to. And this is actually serendipitous as a random event that, Matt, you are our guest, but I recently started rereading the Foundation series by Isaac Asimov, and that's what I want to recommend to people, to read those books if you haven't read them, or reread them if you read them a long time ago.
Are you at second Foundation yet?
No, I'm still on the first book, so I'm working my way through the first one. But it's hilarious because I'm just like, oh my gosh, I forgot all these like things about this. So I'm having a good time.
It's also total data science too. Like Second Foundation is sort of like the data science big data hypothesis. So it's like I'll be interested in your take on that.
So we have Douglas Adams and Philip K. Dick in your intro, and then all of a sudden you're actually currently reading Asimov. I feel like you're covering the
going
gamut.
through a phase is what I'm doing. All right. Who's next?
I'll go next. I had to change mine anyway because I've clearly established that Tim was trying to steal my thunder once again. So this is, I guess, for all the listeners out there who are still a little bit scratching their head and still, when you say reinforcement learning, aren't kind of sure, like it hasn't sunk in. In doing research for this show, I came across a blog that I've never actually seen before, and it's called, I'm going to mispronounce it, but I'll make sure to put the link in the show notes. It's Analytics Vidya?
Analytics Vidya.
Yeah.
Analytics Vidya.
Okay, of course Tim nails it and knows it. Big shock. But there is an article there on what is reinforcement learning, which talks about dog training, which we did touch on in the show, but I'm obviously really big into my dog and we do clicker training, and it was somehow about that example, it just helped everything sink in. So I really recommend that one if you're still a little uncertain.
That was, you actually posted that before the show and I got to read it. That was a good primer. So mine, just to stay somewhat technical, I guess, I stumbled across this in a funny roundabout way. Mark Edmondson has a Slack group for basically anybody who's using any of his Google R packages. He had thrown in there a link to Rugal Vision, which is a package for R that is uses the Google Cloud Vision API. It's comical as you follow the chain to the actual documentation for the package. The authors have in their usage instructions, they say, oh, you need to authenticate with Google. Use the fantastic Google Auth R package. So they actually, in the comments of their sample code, commented on how awesome the Google Auth R package is, which is a package created by Mark Edmondson. So I went in a complete circle, and then circles are an image, so then I actually tried out the package. So I don't really know that I've got an analytics application for it, but it was kind of fun. I took some pictures from various recent trips, and you just sort of throw the image. It's just a little bit of code, and you say, tell me what landmarks you see in this picture, or tell me what tags you see in it. And it does a pretty good, if you've got a landmark, if you've got a picture on red square that, that it will identify it as red square and give you the latitude and longitude. That is kind of a leveraging the power of some of the stuff Google has without needing to fully understand exactly the magic of how they're doing it. But I may post a link to my silly little bit of code I did. I'll certainly post the link to the couple of posts on it. But it really was, it's almost, if you're looking to dabble in R, it really is one that within an hour or two, if you've got your own images where you say, oh, I'd like to see, can you find the faces? Can you identify the nose, ears, eyes, and whatever other parts of a face there are, in this picture? It's pretty cool. So it's just kind of a idle aside, but kind of nifty. Google's doing some amazing stuff, and people are writing R packages to hook into it.
Awesome. Well, if you've been listening and you have thoughts, or you've had a breakthrough in reinforcement learning and you really want to talk to the analytics community about it, Matt Gershoff is on the Measure Slack, so you can reach him there, also on Twitter. And so are we. We'd love to hear from you. And you can reach us on our Facebook page, on Twitter, on the Measure Slack about reinforcement learning, AI, whatever. Only Matt will really understand you. The rest of us will refer you to Matt. Although Mo is starting to become very dangerous.
It's not a competition.
So, we'll see.
It's not a competition.
There was some
Michael.
pointing going on in that show. I'm not sure what that was about.
That was me saying that was a really good question, and I was about to ask the same thing. So,
Sure.
So you claim.
no, that was.
If you are at the Mentor Slack, there the data science channel is the channel
place to
that most
be.
likely people would be talking about that. So
In any case, we'd love to hear from you. And if you listen to the show regularly, and as a further qualification, you identify as someone who really likes the show a lot, and only if those two things are true. No, I'm just kidding. We would love it if you would go rate us on iTunes. So when people submit ratings via iTunes, what that does is somehow lines our pockets eventually. No, it does not do that. Is it helps create more visibility for the show. So we'd like to get out to more listeners. And if you created some ratings and reviews of the show, if you like it, I guess if you don't like it, I can't even do that. Yeah, only people who like the show. Sorry. No, I'm just kidding. Anybody can rate and review, but we would love it if you were willing to submit a rating or review on iTunes. That would help create more visibility. Anyways, we've loved having you, Matt. Again, you know we talk about you on the show all the time, and in a good way, though. So it's healthy. And
we will see Matt in New York at eMetrics here coming up end of October.
Sooner than that, I will see Matt at, I believe,
right.
the DA Hub at the beginning of October. So, yeah, I get to see
Which
Matt
is just imminent.
twice in October. And, yeah, coming right up here. Anyways,
Couple weeks.
but everybody listening, keep on doing that. We appreciate it. And for my co-hosts, keep learning.
Thanks for listening, and don't forget to join the conversation on Facebook, Twitter, or Measure Slack group. We welcome your comments and questions. Visit us on the web at analyticshour.io, facebook.com/analyticshour, or at analyticshour on Twitter.
So smart guys wanted to fit in, so they made up a term called analytics. Analytics don't work.
You okay there, Tim?
Maybe I should have had something stiffer.
You okay, guys?
Yes, we're very excited about cuisine in Australia. Relative freshness. Mo, I don't know what you put in your tea, but it's slightly slurring your speech. So I'm just kidding. I'm joking. Tim, have you gotten down to a light simmer? Sort of.
I'll be fine.
Pardon me, I'm hunting for a pen while you're talking. I don't mean to be a distraction.
Oh, shit. Oh, it's going to be a disaster.
No, so
Oh, it's gonna be a fucking.
yeah, what do you want me to do?
That was good.
Yeah, anyways.
Okay.
Good stuff.
Wait, let's do that again. Hold on, let's do that again. I'm gonna do 10. That was good.
Tim has had a rough week.
Rock flag and reinforcement.